Hi, this is Shlin from MAQ, and today I'm gonna make a small demonstration showing you what is the difference between a vibration damped cutting tool and a standard steel tool. And normally when we talk about vibration dampening, and it's quite difficult to explain, and in this small video I'm gonna show you what is the normal way so say you can feel the difference. On my left hand side we have a MAQ STMD vibration damped turning tool with SDSR card head, you can see, and it has a damper sitting inside here that is trying to attenuate or reduce the vibrations in machining. On my right hand side you can see here's a steel cutting tool that is a normal standard on the market, and it has no damping of course, and made of steel of course, and this is a sound fork, so if you heat on summer you can really sense the vibration on the ball in the front. You can really sense with your fingers, so if you do like this you can sense the vibration that is trying to excite the ball up and down. So let's do the demonstration. And first of all I have a standard tool. I'm gonna put into the chuck, mount it correctly at 7 times the diameter. So the bar diameter is 25 and I'm gonna overhand at 175, so it's a 7 times the setup. And then I'm gonna clamp it in a correct way with a reduction sleeve on the turret. And now we have the sound fork, and what we're gonna do is that we gonna excite the sound fork, excite the vibrations up and down on the ball here, and put it on the tool and sense the vibrations here. So the vibration from the ball is trying to excite the up and down motion, and when you touch the tool has a tension to vibrate, and then it starts to have a collision with the ball, and that's what we are hearing. So I do it again. So now I'm gonna take the vibration damped bar in the similar setup and see what's gonna happen. So of course I'm gonna put it at 7 times the setup. I need the tape rule. So with a 25mm bar, 7 times means 175mm in the overhand length. And when we measure, the overhand length is always from the cutting edge to the clamping end of the cutting tool. So now it's correctly set up, and let's do the same experiment and see what happens. You see there was no knocking backwards sound from the vibration damped turning tool. So that is the difference. I mean, it's really that the tool does not move, so that there was not any knocking sound. So the tool does not have a vibration in the up and down direction, so that there was no knocking sound between the tool and the sound fork. So interesting, right? Thank you for watching, and if you like our video, please subscribe or follow our channels in the down to the left corner. Thank you very much.